Hello, today is going to be on our area formulas. We've got a couple different shapes that we're going to look at. The first couple are 100% review. So the first one is the area of the circle, which we have already looked at this year. It is pi r squared, where we know r stands for the radius. The circumference of your circle, 2 pi r, or diameter pi. You can use whichever one you prefer, just like we learned it before. So if we look at the first example, I want to find the area of the circle. So the area of our circle is pi r squared, r being the radius. So we have 6 squared, giving us 36 pi. The area of our circle is 36 pi. And if you remember when we learned about the area of the circle before, we want to make sure that we are always going to be labeling our answer. So number 2, we're switching up just a little bit. When I look at what is given to me, I'm not given the radius, so it's not as straightforward. I am given the diameter is 20, and the diameter are 2 of those radii together. So from the diameter, I can get the fact that my radius is going to be 10. So it's pi times radius squared, 10 squared, giving me 100 pi. So our area is 100 pi centimeters squared. All right, now we are going to switch to some word problems. The area of the circle is 225 pi meters squared. What is the length of the radius? Again, this is another question that we saw in our circles unit on our test. We know that we find the area by doing pi r squared. And if the area is 225 pi, we want to use that information to figure out what that radius is going to be. We can see that our pi's are going to cancel out. So to find the radius, we square root, and we find that the radius is going to be 15. A radius is linear, so that's going to be 15 meters. Then we use that information to find the length of the diameter. If we go back to number 2, the diameter is the length all the way across the circle, whereas the radius is just halfway. So to find the diameter, I do 2 times that radius value, and I get that the diameter is going to be 30 meters. Okay, our next section here is going to be on rectangles. Your rectangle is base times height or length times width. I feel like you're used to hearing length times width, but length times width is the same as base and height. The area of your square, you could also use the base and height, or because in a square all 4 sides are the same, you could also use the fact that it is going to be side squared. So when I look at number 1, the sides are not the same, so that's going to be a rectangle. The area of your rectangle is base times height. Your base and your height are always going to run perpendicular to each other. And it doesn't matter which one you say is your base and which one you say is the height. So we've got 11 times 6, giving you 66. The area is 66 centimeters squared. If you remember back to the properties of a rectangle, in a rectangle, opposite sides are congruent. So if that side's 11, that side's 11. If this side is 6, then this side is going to be 6 as well. When we switch to number 2, now we notice that we have all 4 sides being labeled as congruent. That means now we have a square. You could do base times height, because base and height are both 11, or we use our special one that it's side squared. The side of our square is 11, so the area is going to be 11 squared, which is 121. In this case, we have millimeters squared. Switching on to our word problem, the perimeter of a square. So this one's a little bit different now when we look at the perimeter of a square. We think about, what do we know about a square? In a square, all 4 sides are congruent. So if I add up 4 congruent sides and equals 40, I take what the perimeter is and I divide it into 4 equal pieces. So each side of my square is going to be 10. Then I use that information to find my area, which is side squared, 10 squared. So then the area of my square is going to be 100, in this case inches squared, making sure that we always do label our answers. Number 4, the area of a square is 64. So we're changing it up a little bit. Still have that square. Sides are congruent. If the area is side squared and the area is 64, that means I'm going to have to square root to find that each side is going to be 8. Now that I know that each side is going to be 8 and I want to find the perimeter is what you get when you add up all the sides. And I have 4 sides of 8, making the perimeter 32. Perimeter is linear, so it's not going to be centimeters squared, it's just going to be centimeters. Number 5, the area of a rectangle is 54 yards squared. Okay, so I know area is base times height. What we just found out is that the area is 54. So I'm going to replace the area, the A, with 54. The base of the rectangle is 6. So I'm going to replace the B with 6. And then I want to find the height. So that's my unknown variable. That's the one thing I don't know that I want to solve for. Since this is 6 times h, we divide by 6 to find that missing value. So here we find that the height of the rectangle is going to be 9 yards. All right, let's go ahead and flip on over to the back side to page 2. Page 2, we are looking at parallelograms. So parallelograms, this one is going to be a new shape that we've never done the area of, but we know about parallelograms. And as we look closer, we notice that the formula for the parallelogram is the same as the rectangle. When dealing with any type of parallelogram, we want to remember from our quadrilateral unit that the base and the height are always going to be perpendicular. That's going to be important because in a square and a rectangle, everything is perpendicular, so I don't have to think about it. When it comes to parallelograms, I need to be careful to make sure that I'm using the 2 pieces that run perpendicular to each other. So our area formula for our parallelogram is base times height. I want to look at the 2 numbers that run perpendicular, so the 2 numbers that form that right angle. So in this diagram, the 8 is going to be our height, the 9 is going to be our base. Now it seems weird, you're like, well, the base, shouldn't that be the bottom? If you remember about parallelograms, opposite sides are congruent. So if the top is 9, the bottom is 9. If the left is 11, if the right's 11, then the left is 11 as well. But we're actually not going to use the 11. That's going to be extra distractor information. We only need 2 numbers. It says it is the base times the height. So the only 2 numbers I need are the base and the height. In this case, the base is 9, the height is 8. The 2 numbers that run perpendicular. So 9 times 8, giving us an area of 72 centimeters squared. And we're going to pretend like we can see that 72. So again, when I get to number 2, I'm looking for only 2 numbers. I need a base and I need a height. The base and the height are the 2 pieces that run perpendicular. So right away, I notice here is my perpendicular. This is my height, but there's no number there. So it looks like I'm going to have to find what my height is. And I want to look to see what is running perpendicular to that. And you're like, oh, right here. And you're right, the 3 does run perpendicular, but the 3 is not the base. If you notice, there's dashed lines. Dashed lines mean that they are imaginary. It's not actually a part of my figure. My parallelogram is this piece right here. So the base has to be one of those numbers. In this case, our base is going to be the 9 because the 9 runs perpendicular to the height. Your height is just the distance between your bases, the distance from the top to the bottom. It's labeled on the outside because it's set up for us to find what that missing value is. That right angle means I can use Pythagorean theorem. So I've got legs squared plus legs squared equals hypotenuse squared. That's 9 plus h squared equals 25. We move our 9 over to get 16. We square root. And our height, that missing height there that we needed, is 4. So the area of our parallelogram, base times height, the base is here is that 9, which runs perpendicular to the height of 4, giving us an area of 36 meters squared. All right, the last one in this section, our word problem. The parallelogram has an area of 48 inches squared. If the base is 16 inches, what is the height of the parallelogram? So we've got our word problem. We think about what we know. We're talking about area of a parallelogram. Since the area of a parallelogram, we use the area formula. It says that it's 48. So the A represents the area. So I replace the A with the 48 because the area is 48 inches squared. The base is 16, so I replace the B with 16. And I want to find out what the height is. That's my unknown. So it becomes 48 equals 16 times h. So to solve for h, I divide by 16. And I find that that height, that missing height that we needed, is going to be 3 inches. All right, our last shape for today, and that is the area of a triangle. That is 1/2 base times height. Just like with the parallelogram, the base and the height in the triangle must be perpendicular. Base and height are the two numbers that run perpendicular to each other, forming that right angle. The height of the triangle can be in 3 different places. It could be inside of the triangle. We can see that right there in example 1. That's the height inside of the triangle. It could be outside of the triangle. We saw this with our parallelogram above. We can see that in example number 2 where the height of the triangle is running outside. Or it could actually be parts of the triangle. So right here in number 3, the height is one of the actual side lengths. So it could be inside, outside, or part of the triangle. It just matters where is it running perpendicular. The base and the height run perpendicular to each other. So if I want to find the area, 1/2 base times height, the base of our triangle runs perpendicular to the height of our triangle. There's my height. The base is this entire piece. This section is 6 and this section is 9, so I have to add those two pieces together to find the base in the end. So that's 1/2 base of 15 times the height of 7. We multiply all of that out, and we end up with 52.5 millimeters squared. In number 2, when I look at this, I have a whole lot of numbers, and I'm not going to use all of them. The formula for our triangle is that the area is 1/2 base times height. I only care about 2 of the numbers, and those 2 numbers are the base and the height, the 2 numbers that run perpendicular to each other. So the base of my triangle is 6, whereas that height of the triangle we looked at before is that 4. So this is the base and this is the height. So we have 1/2 times 6 times 4. We plug all of that into our calculator at once, and we find that the area of our triangle is going to be 12 meters squared. All right, our last one here, again, we care about the base and the height, the two pieces that run perpendicular to each other. What I want you to do now is pause it and find the missing height of your triangle using Pythagorean theorem. Go ahead and push pause. All right, so we have 1/2 base times height, the two numbers that run perpendicular. So in the bottom there, we've got a base of 8. We did Pythagorean theorem, and we found that the height is going to be 6. Then we multiply all of that together to get 24 yards squared. If you did not get 6 as your height, go ahead and push pause and make any corrections to your algebra that you need. I got 2 more left, and then we are done. For number 4, the area of a triangle is 32 meters squared. If the length of the base is 16, what is the height of the triangle? Again, we think about our formula of a triangle. This tells me to use the triangle formula. This tells me that the area is 32. A stands for area, so I replace the A with the 32. The length of the base is 16, so I replace the B with 16, and I've got H. I can simplify. I've got a little bit more complicated of a formula now, so I can simplify. 1/2 of 16, well, that's 8. 8 times H, I divide by 8, and I find that H is 4. So in this triangle, our height is 4 meters. Remember, not meters squared because it's not going to be area. Last one. So for this last one, let's put a star by this. We've got a lot of information going on in this one. The area of an isosceles triangle. Okay, so we think about what we know about an isosceles triangle. In an isosceles triangle, we have congruent legs. So when it says the legs are 13, that vocab word tells me that this is 13 and this is 13. The legs are the congruent pieces. The base is the non-congruent piece. So then it tells us that the legs are 13 and the base is 24. Well, when I think about my area formula, it's 1/2 base times height, and we keep on saying that the base and the height run perpendicular. I have the base that was given to me at 24, but I need to find the height. So then this is where those properties come in. We know that in an isosceles triangle, when the height comes down, it's going to bisect the base. So this is going to become 12, and this is going to be 12. I use that information to look at just 1/2 of the triangle at a time, and I can do Pythagorean theorem to find that missing height. So I've got 12 squared plus h squared equals 13 squared, 144. That's 169. We move it over to get 25. We square root, and that missing height is 5. So in our formula, we have 1/2 the base of 24 that we were given times the height of 5 that we just solved for. We put all of that into our calculator, we multiply it out, and we get 60 inches squared. All right, so that was a lot today for our notes for in class. Make sure that now that you are done, you go up and you show the sub that you took these notes, and the sub will mark you off for having your notes done for today. But you've got to make sure that the sub marks you off for taking your notes. All right, thank you. Bye.